Good day to you all. Evan Snowman here again for the second episode of our series about Sigma notation, working for Imre Local, making a difference. Okay, so we're now going to look at something which again seems to be the problem with this chapter. As we saw previously, the formulae for a arithmetic, okay, so we said if we had a sequence, okay, if it was an arithmetic, we saw that Tn equaled a plus n minus 1 d, I'll rewrite that. And if it was geometric, Tn equaled a times r to the power of n minus 1. Okay, so we saw that was the two formulae for an arithmetic sequence. A sequence is another word for a pattern. Okay, we've changed the words linear to arithmetic and geometric to geometric is substituted for the word exponential. We're now talking about a series. We've seen that S of n equals n over 2 times 2a plus n minus 1 d, or S of n equaled a r to the n minus 1 over r minus 1. We also saw some extra things, and we did mention that what was important was that the sum to infinity would equal a over 1 minus r if r was trapped between 1 and minus 1. Okay? Now, all of this is cool. All of this is fairly straightforward. As we said before, there are 4 variables in each of these formulae, and all I really need to do is make a decision, identify the correct formula, plug in the correct three variables, and do some work to calculate the missing variable. Okay? But what catches people a lot is this new thing which suddenly pops out, which looks as follows. And if drawn correctly, it's almost like a sideways M. Let's say it goes 3p minus 2, p equals 5 to 11. Let's say we do that, okay? Now, the first thing I want to point out is that this is what we call sigma notation. This funny symbol, okay, over here is the Greek capital letter S. That is sigma, okay? Now, what they've chosen to do is they've chosen to use the letter S because S would stand for a sum. Okay? And again, I know that there's sequence only with an S, but just using the word sum because it refers to a series. Okay? So it is a shortened form of writing a series. Okay, so if it was arithmetic, we could write down the series as follows. Okay? What we need to do is to identify then the various components of this notation. And the first component is to realize that this value here, okay, is the term. Okay, so this value here is the term. Okay, so we know, therefore, that for this example, Tn equals, in this case, P, okay, Tp equals 3p minus 2. Now, what you will have noticed there is that you had a fairly cheap, but a fairly easy to understand substitution of the variable. Instead of using n, they are now using p. Makes no difference to our formulae. Just everywhere where there used to be a n, we are now going to use a p. We should be able to, if just by inspection, therefore, look at this thing and say, well, hold on. If that is the case, I can recognize that this thing actually is going to be arithmetic. Okay, so I'm hoping you can see that this thing is arithmetic. Okay, because in many ways, okay, you can see that the type of the term is linear. We've seen in one of the early versions that all that happened was we replaced the word linear pattern with the word arithmetic pattern. Okay, there was a subtle shift with how we wrote the formula, but the concept is that a linear pattern is the same as an arithmetic pattern. Okay, what we now have are a start and an end value. So it says start when p equals 5 and end when p equals 11. Okay, so this one now says, okay, start So I'm going to slightly thicker pen. Okay. Start with p equals 5. And end when p equals 11. Therefore, what we are being asked to do is, if p equals 5, so t of 5 would equal 3 times 5 minus 2. As a result, we're going to get 13. T of 6 would equal 3 times 6 minus 2, which equals 16, etc. T7, T8, until we get down to T11. 3 times 11 minus 2, which is 31. Okay, so in effect, what they're asking us to do is to add up the values 13 plus 16 plus 19 until we get to, it equals, until we get to adding 31. Okay, and we're being asked to evaluate that, okay, to find the value of that. Okay, so what they've done is they've compressed the notation, okay, by saying sigma of p equals 5 to 11 of 3p minus 2, okay? They are telling us to add up all the values from 13, 16, 19 until 31, okay? And we are being asked to find out that value. But the key thing here is that they've compressed it with this notation, and I hope you can see that by doing so, they are saving space, and that might have some impact on maybe computer memory or whatever the case is, something along those lines. But again, because it is sigma notation, we know it is a series. Because of that form, okay, we know that this particular example that we're talking about here is arithmetic. So we know that S of n will equal 2a plus n minus, what am I doing? Absolute rubbish. Because of that format, we know that S of n will equal n over 2 times 2a plus n minus 1 d. Okay? And from our previous conversation, we've said you need to find 3 values in the text and be able to substitute them in. Now, what I'm hoping you can recognize is that 13 will be our a value. Okay, so we can see that a is 13. Okay, we should be able to see that a is 13. Whether you are seeing it from, again, sorry, let's just choose a different color so we can see it better. Okay, whether you are seeing it from the change over there, or whether you're seeing it over here in the 3, what you can hopefully see is that the d value will be 3. And what I'd like you to just look at here is that if they give me a start value of 5 and an end value of 11, okay, I should be able to work out that therefore n equals 7. Now, I'm sure there's some people there saying, hold on, 11 minus 5 is actually 6. But the answer is actually 7 here, because if I include the values as I count them, so the 5th value, the 6th value, the 7th value, the 8th value, the 9th value, the 10th value, the 11th value, you can see that I've actually counted 7 different terms. Okay? So what we learn as a formula is that n will equal top minus bottom plus 1. Okay? So a useful thing to remember is that n equals top minus bottom plus 1. Okay, having identified my 3 variables, I'm going to choose to plug them into this formula. So as a result, the rest is now mechanical or simply calculator work. I'm going to get an answer of 7 over 2 times 2 times 13 plus 6 times 3. Okay, so let's see what the calculator says to me. 7 divided by 2 times brackets 26 plus 18, close the brackets, equals 154. Okay? So my sum in this case would be 154. Okay, now again, we could have gone back to our work and simply said, well, hold on, this one is easy enough, and please don't feel forced to use fancy formulae if you can see a shortcut. But if I simply said, going back to this red line over here, okay, coming back to this red line up the top here, and I simply said, well, you know what? That's actually short enough for me to do on my calculator. So 13 plus 16 plus 19 plus 22 plus 25 plus 28 plus 31, and I do in fact get an answer of 154. So there's nothing that stops me from actually just going and, okay, but more often than not, they'll either use a large number of terms to discourage you from doing this method, or they'll give you the total and ask you to find out how many terms there were, so that the reverse question, and as a result, you won't be able to use this method quite so easily. Okay, so what I'd like to look at now is, again, what do I do if they ask me to do this in reverse? Now, this has become less popular as a question, but it is still technically a question. Okay, so let's have a look at the following. Express. Okay, let's have a look at something simple. 6, 18, 54. So let's just have a look at, okay, sorry, I'm going to quickly change that again. Okay, 6 plus 18 plus 54 plus ... plus, let's have a look at something quickly. So 1458. Okay, in sigma notation. So what we're going to do is we're going to write down the sigma. Okay, we're going to look at these terms. Okay, and we're going to see that term 1 is 6, term 2 is 18, and term 3 is 54. I hope you agree with me that this is not linear, so it's not arithmetic. And since I'm timesing by 3 each time, okay, I know it is geometric. Okay, and it's geometric more specifically with r equaling 3. Now, since t1 equals 6, okay, we should hopefully be able to see that, therefore, that again, by our rules of all sequences, A always equals T1. Okay? So what effectively we got asked to do, we got the bulk of this one right now. We know that therefore Tn equals 6 times 3 to the power of n minus 1. And as we said earlier, this is the term, so therefore this is what's going to go in over here under the term. So we know it's going to be 6 times 3 to the power of n minus 1. Okay? We can start with n equals 1, unless we want to make our own lives difficult. Okay? And now what we need to do is simply work out what is our last value. Okay? What is our final value going to be? And in this case, we're going to do what we've done in previous cases. We're going to say, wonderful, 6 times 3 to the n minus 1 equals 1458, because this is our last term. Okay, we just want to know the nth number, the position of that term. Okay, so we're going to divide by 6. Okay, and we get a value of 3 to the power of n minus 1 equals 243. We could use logs, but I'm going to choose to. Okay, I know that this is 3 to the power of 5. Okay, so therefore n equals 6. So in this case, I now simply write a 6 at the top here. Okay, and that is the equivalent way of writing that expression there, 6 plus 18 plus ... plus 1458 in sigma notation. Okay, it was the term type, the term type or the equation of the term, where we start and where we end. Okay, so now I've got some exam questions that involve sigma notation. Okay, and let's have a look. Okay, so I'm going to go through this fairly quickly if I can. Determine the common difference of the sequence. Well, to start with, they're telling me that T2 equals 8, and they're telling me that the fifth term equals 10. More importantly, they're telling me it is arithmetic. So I know that this is A plus D. I know that this is A plus 4D. And so as a result, I should be able to see that therefore 2 equals 3D. So 2/3 equals D. I've got my common difference. Okay, D will equal 2/3. Write down the sum of the first 50 terms of the sequence using sigma notation. Okay, well, as a result, okay, if D equals 2/3, then what I'm going to realize is therefore A equals 7 1/3, or ultimately 22/3. Okay, I need this because I need to know what the general term is, and what I'm realizing now is therefore the general term is Tn equals 22/3 plus n minus 1 times 2/3. Now remember, I need the type of the term so I can write down the sigma notation. So we said it is a sigma notation. They've told me it's the first 50 terms, so we go from the first to the 50th term, and we know that the term type is 22/3 plus n minus 1 times 2/3. Okay? To determine these first 50 terms, so to determine this answer, we now know that actually we can rewrite this in a different form, and that form would be S of n equals n/2 2a plus n minus 1 d. We've got all our values scattered around here on the page. Okay, we know that we know that n equals 50. We know that a equals 22/3. We know that d equals 2/3. So we've got 50/2 times 4/3. Sorry, lies. 44/3. Okay. Plus 49 times 2/3. And I'll plug it into calculator and get an answer. So 25 times brackets 44 divided by 3 plus 98 divided by 3 equals 3550/3. Okay, and there's my answer. But again, please notice how they asked you for question 2.2.2 to express the thing in sigma notation. Okay, this example now also involves an arithmetic sequence. Okay, describe Tn of the arithmetic sequence. Well, again, we're going up in threes. Okay, so therefore we can see that 3.1 is going to be Tn equals the first term plus n minus 1 times 3. Okay, we can rewrite it in many other formats, but that is the format they are looking for here because we are using the notation of arithmetic and geometric sequences. To find 3.2, okay, we now know that all we have to do is substitute in 43. So we're going to get minus 1 plus 42 times 3, which is 126. So I'm getting an answer of 125. Again, only worth 2 marks. So right now, this was fairly friendly. 3.3, okay? The only change now, okay, is that they haven't given us the end value. So all we're going to do is we're going to leave the formula in terms of n, as they've asked us to do, okay? So again, the sigma value of k equals 1 to n of tk in this case would be equal to, we've said we want to change it to the other notation. Okay, so we want to change it into S of n equals n over 2 times 2a plus n minus 1d. Okay, because of this fact here, we've seen we don't know what the n value actually is. So we're going to leave the n value behind. Okay, and what we do know from earlier is that a is -1 and d is 3. So we can do what we can here, and in this case, we're going to get n over 2 times -2 plus n minus 1 times 3, which we could simplify, and we could simplify it if we wanted to. We could go further, okay, which would therefore be what? Okay, n over 2 times 3n minus 5. And for me, I think that's pretty much as far as I would probably go. I wouldn't go much further than that. Okay, you might want to go to 3 over 2n squared minus 5 over 2n if you really felt the need to, but I probably wouldn't. Okay, I think that the answer for 3.3 would be almost our second line there. Okay, I do know we're running out of time quickly, so I quickly want to look at this last one. Okay, so again, they've worked backwards. So again, the key problem here, and again, it's in the detail, okay, is to notice that they've told us that it's a sum to infinity. Okay, so because this is a sigma notation, sigma being a sum, we are talking about here a sum to infinity. Okay, and because we've got a value, we know that therefore this is a over 1 minus r. Okay, they tell us, okay, that that the sum to infinity of this thing is 27. So we know that this value equals 27. And they tell me that S of 3 is 26. Okay, so S of 3 is 26. Okay, so that is equal to a, sorry, let's just be a little more clear on what I'm doing. That is equal to T1 plus T2 plus T3. So 26 equals A plus AR plus AR squared. Okay, now what we have a problem here is, okay, we don't have a easy way to solve this. So again, because they've given us two pieces of information and there are two variables that we don't know, okay, we are forced to use, well, there's the first piece of information, there's the second piece of information, we are being forced to use simultaneous equations. Okay, so I'm going to choose to, from number 1, okay, I'm going to choose to write down that therefore A equals 27 times 1 minus r. Okay, and as a result, I'm going to get an answer of 26 equals 27 times 1 minus r. That's 27 1 minus r times r plus 27 1 minus r times r squared. What we're going to get here now, therefore, is that 26 equals 27 minus 27r plus 27r minus 27r squared plus 27r squared minus 27r cubed. Okay, I'm going to put this all together. I'm going to get 26 equals 27 minus 27r cubed. Okay, and so whereas at one stage the algebra looked quite long and was taking quite a lot of space, it falls apart quite quickly because what we see now is that therefore 1 over 27 equals r cubed, and therefore 1 over 3 equals r. Okay, we were able to find the constant ratio of our series. Okay, I hope you realize that sigma notation only appears to be frightening. It is unfamiliar initially, but once we get used to it and we practice it a little bit, it is not all that complicated or all that threatening to our success in mathematics. All the best. Thank you.